Hello, scholars. For week 5, we are looking at equations. So this is your tutorial video for week 5, our equations module. And specifically, we're going to look to write one variable equations and then also solve equations within the context of real-world mathematical problems. And I'll show you how to do that. So for us to be successful, we kind of have to have an understanding of what equations are. And equations are our math phrases with symbols, numbers, variables, and an equal sign. This is where they are different from our expressions, which we looked at in week 3. Equations will have an equal sign. It's showing two equivalent expressions. And because of that, we're able to use what we know about inverse operations and kind of the job of that equal sign, which acts as a balance, to solve equations. So if you look at my example where I say, for example, 3n plus 5 is equal to 17, I can also annotate or just cover up completely this equal sign in between both of those things, and it means the same as. So 3n plus 5 is the same as 17, or 3n plus 5 is equal to 17. So what I'm going to start attaching in my brain is the value of n, because I see n as that variable, thinking back to those math vocabulary words that we're learning. Whatever value n holds on to, it has to it has to ensure that this side of the equation, it ultimately ends up being 17 as well. So that kind of restricts what n can be, but also knowing that helps me figure out the value of n, my unknown, my variable. So let's look first at writing some equations. And this is similar to how we wrote expressions. We're going to annotate and interpret parts of our problem to figure out what to do. It says Ms. Player spent $17 on snacks at the movie theater. She spent $5 on a large popcorn and bought a certain number of drinks for $4 each. So what this is signaling in my brain is when I see that Ms. Player spent $17 on snacks at the movie theater, my brain's thinking, oh, okay, that was my total cost. So I know that one side of my equation is going to equal 17 because that total cost is 17. And since this is an equation and I know that I do use that equal sign, I'll go ahead and put it there because now I have more information. I know I spent $5 on a large popcorn, and I'm only seeing that I've done that once. So I'm going to just go ahead in my mind think, okay, I'm going to add 5. That kind of looks like a constant to me if I'm thinking back to my math vocabulary. And then bought a certain number of drinks. That's unknown. And I remember from the previous weeks that when I have an unknown, I can use a variable to represent that unknown. So a certain number, not sure how many. And I'm going to use n for certain number. I like that variable. For $4 each. So my brain is also thinking I must have done that a certain number of times, which makes my brain think of multiplication, that I must have bought like drinks worth $4 a certain number of times. So what I can do now is finish that other side of that equation. What goes on the other side of that equal sign is that for me to spend $17, I had to have spent $4 on drinks a certain number of times. And here I'm showing multiplication by using a coefficient 4 with that variable n. And then I also spent $5, here's my constant, on a large popcorn. So 17 is equal to 4n plus 5. Now looking at that second objective where I want to solve equations. And I mentioned at the beginning of this video that we use what we know about an equal sign in the sense that it means the same as or equal to. So now my brain is thinking whatever value of n that exists when I multiply it by 4 and then add 5 to it, it's got to equal 17. So here's how I can manipulate, and I'll show you on the other margin, how I can use that equation from the previous problem to figure out how many drinks did Miss Player buy. I bought a certain number of drinks. So now I want to solve for n. So using my equation, 17 was equal to 4n plus 5. And in your other tutorial videos, you've also seen that balance picture where I use what I know about inverse or opposite operations to make sure that my equation stays in balance. So when I'm looking at this equation and I want to solve for n, I want to get n all by itself so that it's really easy and straightforward for me to see what n is equal to. But I see, first of all, I have this coefficient over here. So if I want this coefficient to be gone and disappear from this side of my equation, I can actually subtract 5. And you know that positive 5 and negative 5 are opposites. They live the same distance from 0 on opposite sides of that number line. And so that actually equals 0. So I've removed it from that side of this equation. But to keep things in balance, I have to do the same thing to the other side. And 17 minus 5 is 12. But now my equation's looking a little bit friendlier, because now I see that I only have 4 times n is equal to 12. And I mentioned also inverse operations. And if I want to isolate or get n to be all by itself so I can see exactly what it's equal to, then I know I see a multiplication problem on the right side of that equation. I see that my coefficient is that factor that I multiply by my variable. And so if I want something to show me that opposite, that inverse of multiplication, your brain's probably already thinking, well, that's division. So if I divide by 4, since 4 divided by 4 leaves me with 1n, which is all I want to solve for, is just one. I want to know the value of one drink, 1n. I no longer have that coefficient 4 on the right side of my equation. But to keep things in balance, like it's that scale, I also have to divide 12 by 4. But when I do that, scholars, that 1n that I'm left with, since 12 divided by 4 is 3, I can now see that n is equal to 3. Ms. Player must have purchased 3 drinks at $4 a piece, which is equal to 12. And then I bought that large popcorn for $5, which is equal to 17. So on that note, our super sneaky secret word should probably be popcorn. See you later.